Hello, everyone. My name is Ruslan, and today we'll talk about not put everything in the cloud. So we'll talk about the air-gap observability on the edge and QR code for the questions. We will have Q&A session in the end. Don't worry, we'll put this QR code in the end again. So my name is Ruslan Dautov. I'm based in Berlin, Germany, and working as a site reliability engineer, senior site reliability engineer at ZEDEDA, almost 4 years. And I participating in on-call rotation and operation engineering. So let's talk about the agenda. We will have a look on a problem statement, why the cloud-based monitoring it doesn't work. In the cases of the edge observability, we will consider the several customer cases for the oil service company and the solar tracker, and we will have a look on a solution and takeaways. So, problem statement. We have a dependency, and we expecting that everything in data centers, and you have stable connectivity, but is not always available. So connectivity is a king. When the customer or the big enterprises provisioning thousands of devices, you have the data waves of the workload which can come on a production system and can create the bandwidth hogs. Latency issues, and especially security. When you transfer something like valuable in the logs, which is critical, it's important to be localized. So air gap is completely blind spot. In that cases, you're not able to provide the cloud-based solution and provide the telemetry on a spot. So let's talk about the first case. It's one of the largest oil service company. It's one of our first enterprise customer. Fantastic workloads which running on an edge device, on the tracks, and these trucks moving on oil well facilities. So they're running fantastic workloads, and once in a day, they came to us with technical requirements. Guys, you need to implement the radio silence. And we're like, why? So they start explaining that these trucks visiting the oil facilities, and some facilities handling explosive. So radio silence is critical to not trigger what you shouldn't trigger. Yeah, I will say the technical requirements, it's kind of mind-blowing. But to see that, what kind of workloads they're running, it's Windows virtual machines together with Kubernetes cluster and AI models which utilizing the GPUs. And imagine all these things running on a truck, and this truck is moving. So in the same time, because of radio silence, trucks completely disappear from the telemetry, and you will not get any logs, any information from the trucks till the truck back online. So radio silence came with the interesting challenges. First, you need to implement radio silence, and the second, when you send the signal and device go to a silent mode, how to tell device that now it's okay to go back online, because device sitting in radio silence mode. This is one of a critical, I will say, challenge which we have, and we solve that with local utilities to, when the engineer turn on back online the system. Second case, it's a PV hardware. It's one of the largest solar panel tracker company with hundreds deployments around the world. And if you have seen the news, latest news from the Spain and Portugal, downtime in this type of facilities is quite important and I will say critical for the energy production system. This comes with new challenges. The provisioning of device and deployment, and between these two events can be happen like 6 months or 1 year. It means that first sign of telemetry you will see immediately on your monitoring and observability systems. And for the half year, this device will disappear. In that case, it's one of a challenge. And second challenge, it's no IT dedicated specialist on a field. It means that you're not able to break device or damage or make it unusable. So no one will come and power cycle the edge device. This is hard. This is a lot of challenges, but yeah. And to understand how distributed this type of deployments can be, I'm showing the the map of the edge devices which connecting via satellite connectivity to our production systems. It's only the sample of one of a customer, but you need to give it a view of the scale, how distributed our solution, how distributed our deployments, and how big it is. So let's talk about the solution. ZEDEDA founded in 2016 and providing the one of a SaaS solution which help you to orchestrate and manage and control the edge deployment on your hardware. So it's come together with the global marketplace where we store the thousands of different workloads, and we also have more than 100 edge devices which we certified, and we make sure that everything running stable and without any issues. And the second product which we open sourced, it's Edge Virtualization Engine. It's operation system under Linux Foundation, under Apache license, and from 2016 we contributing to the open source, where this engine give you the ability to run the virtual machines, containerized workloads like Docker containers, Kubernetes workloads, and any others. And this is really secure because we're not allowed any console connectivity or SSH connectivity to the edge devices. Everything goes through the EVE API. We call that our ZEDEDA cloud. Internally, we call that Z cloud. So usually, I might use that term. And what the difference between the air gap and radio silence? So air gap, it's a term from the computer networks when certain system, complex or data completely isolating from the other networks, and especially internet. While the radio silence, it's term when related to radio wave communications, and when you temporarily shutting down all communication till a special order to back online. And how it's related to us. We have cases when the edge device in an air gap environment or in a radio silence mode and completely losing connectivity with the Z cloud. In that cases, edge device not stop, not disrupting the workload. It's continue working, and without any issue, will back online when the connectivity will be restored. Second case, when the all deployment of controller and edge devices inside the air gap environment. This is one of a complex case for our deployments, and we today will share how we're handling both cases with our observability stack. So when we start talking about the observability, I will introduce our teammate, Umka. Umka, one of our user watchdog accounts. So it's usually tracking all the CPU spikes, barking for the Opsgenie alerts. Fantastic teammates. So let's talk about our observability stack. We actually migrated from the Datadog 2 years ago. That's why this stack was, I will say, not relatively new, but we migrated. So Prometheus, Grafana, and Thanos. Prometheus we usually use for our backend system to track all the application which running on a production system. Grafana, fantastic product with a lot of integration with different tools, different data sources, and which give us a unified experience between the different production deployments. And Thanos, because we're receiving tons of logs and tons of telemetry, it's important for us to make the global queries across all our production deployments. And this free tools is not the complete set. So we're tracking the Istio, EKS, if we deploy it in the cloud. We're actually deploying in AWS, GCP, and Azure. That's why to get the telemetry from the managed Kubernetes environment for us is important. In InfluxDB, we're using the second version, and we're keeping the higher and I will say bigger virtual machines for this type of workloads because we have high cardinality of the data. And this type of data, when you construct an analytical request for the many time series, can spike this CPU and memory. That's why we are keeping the bigger VMs. And I'm happy to see the presentation today that's Influx 3.0, solving a lot of performance issues. OpenSearch. OpenSearch is not just one instance. Actually, OpenSearch represented in our deployments by clusters, multi-node clusters, and we have two multi-node clusters which handling different workloads. One, it's for the logs which coming from the devices, and one for the internal apps which working on our production system. Altogether, it's represent this type of simplified picture of our observability stack. So this unified, it's one cluster. Of course, we have tons of microservices which running beside, but overall, it's EKS, logs, Istio, InfluxDB, OpenSearch, Prometheus, Grafana, and Thanos, which we're actually using the Prometheus Alert Manager, which sending the alerts to Slack, Opgenie, and FireHydrant. Because Opgenie decided in the 4th of June to stop selling the Opgenie, we prepared for this type of migration. We choose the FireHydrant. So this type of deployment represents the one unified cluster which we can deploy in air-gap environments or inside our systems, which represent our, I will say, multi-cluster environment. This is a picture of, I will say, briefly introduction to our multi-cluster deployments when we deploy in GCP, AWS, and Azure. And we also deploy in different regions and different countries. That's why for us it's, I will say, really distributed deployments, where the edge nodes can be connected and disconnected from each deployment, and the air-gap environment can be completely isolated. So we're using the Loki for our IT ops and the security operations when we sending the logs from our internal IT systems. For example, like Cloudflare, Okta, when we tracking all the access to the device logs data. For example, engineer goes to the deployment, have a look on what kind of logging existing related to that customer. And we're tracking all this connectivity authorization to the Loki. Thanos give us ability to not transfer tons of data to the centralized observability stack, and we can make the queries across the whole production system and deployment. Grafana give us a unified experience between all the deployments. It's because we're using the Argo CD and GitOps frameworks to deploy the all production systems. It means that when the developers log into each cluster, it gives them unified experience between the deployments. And let's talk about the one of complicated part. And complicated part, it's air-gap environment. When we don't have connectivity with centralized observability stack, and cases when this devices, it's only working in that enterprise environment. So in that case, we keeping the virtual cluster inside our infrastructure to keep the all information about this cluster that's we know that which version, which kind of configuration. And we know that somewhere there, the real cluster is running, and we need to provide the security updates, new versions, configuration changes, and extract the logs back to track the all information what's going on there. So we first of all pack our container registry, Helm charts, Helm museums, vault secrets, pack, encrypt, ship it to the air-gap environment, deploy that, and extract the logs and metrics in a back way. So this exactly represents our multi-cluster deployment, and centralization gives us ability to unify all alerting system to one place and send the alerts to the Slack, Opgenie, and the fire hydrant. And of course, Thanos gives us ability to store that data for the longer time, because we have terabytes of logs which coming from the edge devices, and we have different retention period for the device informations, because it can be terabytes, and we store that up to 30 days or 90 days, or for the certain cases, we can store it for the 1 year. That's why for us, it's critical to store that for the longer time, and also to track all the changes in the disk deployments. Also, let's, I will say, continue to takeaways. Takeaways? In our cases, you need to store everything in a local. All observability stack should be localized. Also, deployment and the cluster should be self-sufficient to provide the all monitoring stack, to provide the all ability to troubleshoot devices on place without the transferring data back. And also, I will say, mind the gap. If you want to learn more, please visit ZEDEDA.com and visit our open source project, Eve. Also, today I can announce something new of one of our, I would say, achievement. One of a big logistic company called Maersk, which have hundreds of vessels around the world and shipping containers, choose us as technology partner. And that's why we also will be deployed not only trucks, not only trains, and we also will deploy on the ships. So I want to say thank you. I want to say thank you for your attention.